Okay, we're going to combine lesson 3.4 and 3.6 because basically we're doing the same thing in both of these lessons, but one of them we're dealing with decimals and one of them we're dealing with whole numbers. So we're just going to piece it all together. Okay, so in example 1, we're going to do exactly what we learned to do in lesson 3.3, which is solve multi-step equations. Remember, the first rule, what you always want to do is combine like terms first. And I'm going to write that up here so we don't forget. Now, what is the only rule that trumps combining like terms? Who can remember that? That's the distributive property. So when we see that, then we need to do distributive property, then combine like terms. But I look in this first example here and I don't see any distributive property. So I know I need to combine like terms. So let's look for our like terms. I know that 7x is a like term and negative 2x. Now I locate my equal sign. It's right here in the middle. They're on opposite sides of that equal sign. So I know I need to get one of them to this side. And I always like to move to the left side so that my variable's on the left side. But you know what? If you wanted to, you could move this 7x over here. It really does not matter. You should still get the same answer. Okay, so let's say I wanted to move the 2x to combine with the 7x. I need to do inverse operation. Since 2x is being subtracted, I add 2x to both sides. Now, did you notice I did not divide by negative 2 because I'm not trying to separate the 2 and the x. I'm not trying to get the x by itself. I'm trying to move the whole thing over. Okay, so I add them together and I get 9x. Remember, it's not going to be 9x squared plus 19 equals 55. Now, I need to get my other like terms together, which are 19 and 55, which means I have to move the 19 over to this side. So I subtract 19 on both sides. And I get 9x, I'm going to write it right up here. 9x is equal to 36. Now I just solve for x. Divide by 9 because what's happening between the 9 and the x? Multiplication. So division cancels that out. Divide by 9 here. And I get x is equal to 4. Okay? Remember, you can always plug it in and check and go, okay, 7 times 4 is 28 plus 19. And you would get your answer there. That would be 47. And then you could do negative 2 times 4, which is negative 8, plus 5, which is also 47. So you know that both sides equal one another, and you've done it correctly. Okay, so let's do the same thing. Let's combine like terms. What are my like terms? 6x and negative 3x. So I'm going to move this negative 3x over here, and I see that it's negative, so I'm going to add 3x to cancel it out. And I get 9x plus 22 is equal to 31. Then I'm going to subtract 22 to cancel it out, and whatever I do to one side of my equation, I have to do to the other. And now I get 9x is equal to 31 minus 22 is going to be 9. Divide by 9 on both sides, and x is equal to 1. Okay, so basically we're doing the exact same thing that we did in 3.3, except for we just have more than one set of like terms to combine. Okay, so let's do this again, but let's see. This time, okay, I've been moving, in the last example, I always moved the like term over here. But let's see, if I were to move that 6y over there, what would be left on this side? Absolutely nothing. So I say, okay, my like terms are negative 9y and 6y. So in order to combine them, I just add 9y to both sides. Cancel it out, and I get 80 is equal to 15y. Okay, now I can just solve for y. Divide by 15, divide by 15, and y is equal to, what I get in my calculator here is 16 over 3. Now, this is where you need to pay attention, because if the directions say round to the nearest tenth, then that means my answer should be a decimal. So all I need to do is click the S to D button on my calculator, and I see that it's going to be equal to 5.33. So again, depending on what your instructions say, if it says round to the nearest tenth, then your answer has to be in a decimal. If it does not, then it is fine just to keep it just like this or to change it to 5 1/3. Either one will work, okay? But just remember, if it says round to the nearest tenth, it has to be in decimal form. Okay, so let's do the same thing on this next one. I want to add 12W to both sides. Cancel this out here, and I get 64 is equal to 18W. Divide both sides by 18, so that cancels out here. Again, I'm going to plug it in my calculator, 64 divided by 18, and I get W equals 32 over 9. Okay, so let's say this were to say round to the nearest tenth. I'm sorry, that's supposed to say hundredth, not tenth. This is supposed to say hundredth, okay? Because I always want you to round 2 decimal places, okay? So let's say it says round to the nearest hundredth. In your calculator, you're going to get 3.555, and it just keeps repeating. So what you do to round to the nearest hundredth is you look at the number in the hundredth spot, which is the 5. I look to the number directly after it, which is also a 5. Remember, if it's 5 or greater, this number right here in the hundred spots gets bumped up. If it's 4 or less, that number stays the same. So I know when I round, it's going to be 3.56 is my answer. And you have to round correctly in order to get credit. Okay? So let's do example 3. What do you see here that we're going to have to do first before we combine like terms? Distributive property. And if you look closely, I've got quite a bit of distributive property. I've got to distribute the 4 here and the negative 2 here. So let's do that first. 4 minus 4x plus 3x equals negative 2x minus 2. All right, so let's start combining like terms. Now make sure you pay attention to your sign, because what kind of 4x is that? That's a negative. So negative 4x plus 3x is negative 1x equals negative 2x minus 2. So I'm going to add 2x to both sides because I want to combine like terms now. So I've got 4, negative 1 plus 2 is 1x equals negative 2. Now I need to also combine my other like terms, which are 4 and negative 2. So since 4 is a positive, I need to subtract it from both sides. 1x is equal to negative 6. Remember, same signs, add and keep. All right, since that's a positive 1, remember what we said we could do with that is we could just totally drop it, and my answer is x is equal to negative 6. Okay, now remember the thing that I told you in lesson 3.3 was if there is ever a random negative sign on the outside, what do you do right before those parentheses? Write a 1, because that is a negative 1 that needs to be distributed to everything inside parentheses. So I'm going to have 6y minus 3y plus 6 is equal to 5y minus 4. Again, I'm going to combine like terms. 6y minus 3y is 3y plus 6 is equal to 5y minus 4. Now I'm going to subtract 5y on both sides so that it totally cancels out. And you say, well, why did you subtract 5y? Because that's a minus sign. No, okay, the negative sign goes to the 4. 5 is a positive number, so in order to do the opposite, I subtract it or make it a negative. Okay, 3y minus 5y is negative 2y plus 6 is equal to negative 4. So I subtract 6 on both sides because remember, I'm still combining like terms at this point. Negative 2y is equal to negative 10. And I divide both sides by negative 2. What's a negative divided by a negative? How many negative signs do I have? 2. So I know my answer is going to be positive 5. Okay, last example, and look at what these instructions say. Round to the nearest hundredth. So we've got decimals to work with. Good thing that you have a calculator and that you can use it, and we will put it to good work. All right, so we got to combine like terms. We've got a like term here and here. So let's move this negative 7.28x over to the other side. So if it's a negative, the way that I move it is to add 7.28x. If you notice, it's opposite signs. So I add 7.28x over here. Okay, take out your calculator, plug in 9.92 plus 7.28, and you're going to get 17.2x minus 6.13 equals 5.96. All right, again, I still have like terms here that need to be combined. So I need to move the negative 6.13 over, so I add 6.13, and I get 17.2x is equal to, let's add these up in our calculator, 5.96 plus 6.13 is going to be equal to 12.09. Divide both sides by 17.2. And let's see what our x is going to equal. So I do 12.09 divided by 17.2. Again, plug this all in your calculator. And your calculator is going to give you a very long decimal. 7.0, I'm sorry, hold on, let me write that differently. 0.7029069767. So it goes really long. That's how far my calculator goes. Nearest hundredth. So let's look at the hundredth spot. That's the 0 right here. So I look to the number behind it. Is it 4 or less, 5 or greater? If it's 4 or less, the 0 stays the same. If it's 5 or greater, the 0 gets bumped up. Well, it's a 2, so it's 4 or less, so I know that x is equal to 0.70. And that would be my final answer. Okay, so that's how you do lesson 3.4 and 3.6. We're actually not going to do this last example today. I want you to go ahead and just work on the, well, you would have already worked on the worksheet from Miss Steinke.